Welcome back. This is Mike again from N3K. So today we are parsing the messages we're going to receive through the server or through the lanes, and that will be done using modal behavior once more. In case you don't want to use modal behavior, create your own update loop out of this and then call the update message pump function that I'll show you in a second. Speaking of which, we are going to start on which side should we start? We're going to start on the client, or actually on the server side. So the code's going to be basically the same, but I'll do it on this side first. We will start by having a update, private void update. As I mentioned, this is for mono behavior, and the function that is not going to be for mono behavior is the update message pump function. So what is this exactly? This is a function that does not exist. By the way, I tend to do that quite a lot. I'll write down a function that does not exist, then I'll declare it. So if you guys are a little bit confused, don't worry so much. That's just something I do. So taking this function, we will write it down here. You can make this private, but as I mentioned, if you're stripping down mono behavior at one point, you'll want to have this public and call it from somewhere else, somewhere that has your while loop in it. Okay. So what are we doing today? We're looking at the messages we receive. So this includes the connection request that we've done in the last episode, the connect function we had on the client. This also includes disconnects, and this includes data event. So if we're trying to send a specific message like this is my authentication request, that's a data event. How do we go about doing this? What kind of code do we need to set this up? Well, we're going to start by looking at if we are started or not. If we're not started, let's return. We don't want to be looking for messages if the server has not been initialized just yet. And then we declare a couple of fields. Here they are. Int receive host ID, int connection ID, and then int channel ID. This first int is to know which platform is sending me the message. Is it web? Is it standalone? This will let you know. So which platform is it coming from? Second one is going to be connection ID. As a server, you'll have multiple clients trying to connect to you, maybe up to 100 in this case. They will all have a specific int that will define who they are. So your first client is going to have connection ID 1, your second client is going to have connection ID 2, and if at that point connection 1 decides to go away, disconnects, and do something else, the third client that joins in, he's going to take over that spot. So connection 1, that's just a small specification I wanted to put out there in case you get confused. So they always take the smallest number in terms of connection and they just ramp up from there. So third one, channel ID. Which lane are they using? Are they using the reliable lane, unreliable lane, the delivery at all cost lane? You can know that information with this int. Now I'm declaring them, they're on 0 right now. We will fill them later with another function, you'll see that in a moment. But before that, we need to declare more stuff, which is basically the following. A byte array that will hold our payload, that will hold our message. So if you're receiving message, like a custom message that you've made, your authentication request, that's where the information is going to be stored into the receiving buffer. Now the buffer is going to have a maximum size in this case, byte size. We still don't know what this is, we haven't declared it just yet, but we'll get to that in a second. Second thing is going to be data size, the actual size of the message. We might have 1024 byte free, but our message could only contain 1 byte. That can happen sometimes. You're just sending a boolean through the server. It might be possible that it only use 1 byte, so that's data size just to know how far you should actually read. And finally, a byte error. I'm going to get rid of this one. Why? Because we have one at the top here in the client at least. We're also going to have to create one over here. So private byte error. And I'll just use that globally across my my script. Okay. Now we're also missing the byte size. I'm going to go at the top and declare that with my other const. And my byte size is going to be of 1024. Whenever you write a message, you cannot go beyond 1024 byte. Now, how much is 1024 byte? 1024 byte isn't really a lot. Well, it's a lot, but it depends on what kind of information you're sending. So it fits 8,000 and about 200 booleans. You could fit 8,200 booleans. So that's That's a good chunk of information. But if you're sending, say, a database over, that is not going to fit at all. So what happens if you have messages that are bigger than your regular packet? Well, you can also send them. That was a lie. You can send messages that are bigger than that. However, you're going to have to think about that beforehand and implement a specific lane for those, so a specific channel. If we have a look again at the initialize over here, we were adding a channel of type reliable, but in case you want to send something like a database and it has to go through, then you can use reliable fragmented, which means that each message is guaranteed to be delivered, and it allows you to have a message with up to 32 fragments per message, which means, so your 1024, that's the amount of byte. You can also do it times 32 on that on top of this, and now you're sending that much information, that many bit through the message. But gonna make sure that your message is actually being sent on the right channel, the reliable fragmented channel in this case. Okay, good. It is not something we're doing in the first part. It's something we are going to be doing in the second part in case that everybody just gather around and start shooting bullet and it just goes like crazy. But we don't need it in the first one. We're sending very, very simple message, and to be honest, it could even fit in, say, even less than 256, but we'll keep it on 1024 until we're ready to lower it down. And what I mean by that is, let's make sure we create our whole application and then we test out and read our messages, how big they are, see if we ever excel. Like, if we never go past 256, let's lower it down. It's going to help with our bandwidth, it's going to help with everything. But when you're in production, or sorry, in development, don't do that. You're gonna end up having problems or errors that are really hard to debug, and then you're gonna have to think, okay, so why did my message get cut halfway? Oh, it's because it just wasn't big enough. It's not really explicit. When you have a problem with this, it won't tell you. So just make sure you're fine during development, and then if you want to do optimization, do it when you're completed. So back to our shapes, how exactly are we filling in that information? Well, we're doing it with the network transport receive function. And receive has a lot of out parameter, and this is what we'll need. So these are the out parameter. These are the parameter that will be filled in. We'll start with out receiving host ID, out connection ID, out channel ID. So these three values will be filled in. And then we have the byte buffer. That's the receiving buffer we just declared. So rec buffer in this case. Buffer size is our so the buffer size is actually rec buffer dot length, and then the receive size out data size, and finally the error is one we globally have at the top. Now the receive actually returns us a network event type, and we'll need this. So let's actually store that right here. So network event type, and we'll say it's equal to receive. So let's quickly have a look at this thing here. We are receiving our message. We're looking at the message bump, and if somebody sent us a message, in this case, if we're the client or if we're the server, it can be any client. So if we have a message, we fill in all that information. So we're going to look at which platform is that client sending it from, what's his connection ID, so which client is it, which channel is he using. That's the information. The payload is actually going to go through receiving buffer, so that's our data right in there. Very important. We're going to know how big that data is, and also what's the real size of that data. So the dot length over here is always 1024. We could technically change it to byte size, but I'll just leave it at the dot length. You know what? No, that's stupid. Let's put that on byte size. Everything we can optimize about the server code has to be optimized. Okay. Data size is going to be the actual data size of that. So if we're only sending one bit through it, or one byte, this will say 1. And finally, out error. In case something goes wrong, we will have that information through the network error enumeration. Alright, so we also receive a network event type. To show you what this does, we'll put it in a switch, because we'll have to eventually. Let's have a look at what this is. Broadcast event, connect event, data event, disconnect event, and also nothing. We know what type of message is being sent using this network event type. Now, most of the time, you're going to see this one. That's your data. That's your custom data that you've made for your game. That's something very specific you have. That's your position update. That's your buy request. That's thing that you've created. Now, the system, the network transport lower level API, will also have connection event that will be done automatically. This connection event also will be done automatically, and broadcast event. We are going to create a case for all of them. So, in case nothing happens, and that's basically every frame, because you're not always sending messages, especially in this application, that's every frame, right? Let's just not do anything. We don't need to put a debug.log to let us know that this frame, there was no message. We don't really care about that. Next up is we could do the connection event. That'll be nice, so let's do a debug.log and say, actually we'll do a format here, so string.format. We'll say player, or actually user, will give out its connection ID. We have that information, has connected like this, and his connection ID is the one we received just at the top there. So with this code, we'll be able to know user 1 has connected, user 2 has connected. Now that's cool and all, but let's also do that for the disconnect. So disconnect event. Then we'll do a sad face here. Okay, it will work the exact same way. Even if the person is disconnecting, we'll still receive all that information. We'll still know what is the connection ID, what is the receiving host ID. In this case, channel ID is not going to be equal to a reliable channel. It's going to be equal to 0. This is not a message that we personally send through our channel. It's like inside of the Unity transport layer. They have their own channel for like message connected event and disconnected event. So this is going to be 0, but you won't see it anywhere else but there. So it's a bit confusing. Maybe I should not have shared that information. But just know that the channel in this case won't matter. The information is going to go through because it's very, very reliable. It's like it's almost all cost delivery to know whether or not a client has connected or disconnected. But don't quote me on the all cost delivery. I might be wrong there. And then finally, there's the broadcast event, which we're not going to be using. So I'll just leave it there with the default. So I'll do default and also a broadcast event, and I'll just say debug.log unexpected event type or network event type. This will never be called, but in case, I'm making sure that, you know, it's actually being treated. Before that is the most important one that I haven't put. The data event. This is where all the magic happens. And I'm telling you, this is going to be where our code lies. So instead of putting a debug.log string format, I'll just say something like data. This will change very, very soon. And there it is. That is our message pump. Now, is it being called on the update? I believe so. Yep. Which means that if we run this, we'll be on the server listening for message, and those messages include the connection and also disconnection. On data, we don't do anything with on data. We don't send message through our client just yet. Therefore, we don't need this. But let's have a look at this thing in the actual engine. So I will be starting my server. Make sure I put clear on play. Yep, it's there. It's opening connection on 26,000, and I'll be starting my client. As you can see, user 1 has connected. We know that we've been connected. Here we don't have a confirmation message simply because we're not receiving anything, but we know that we've been connected because the server knows. And if I'm about to kill this application on the left, the client, you'll see that after a small time, user 1 has disconnected. If I start this again, you'll see that user 1 has connected. We're not user 2 now. We actually taking the spot of the smaller int. So thus far, our server knows we're connecting. Now it'd be good if our client also knew that information. So we'll be opening up the dual coding setup. Let's actually do that here. And you probably guessed it. It's going to be mostly the same thing. So let me go to the top here, grab my update loop. Exact same thing on the client side. This whole thing, there it is. Copy And we're going to need to declare a couple of things here, such as the byte size. So I'll grab my byte size again, put it at the top. So now we know how big a socket is. This is also very important to have on both ends. Like if it's not a match on the byte size, then you're gonna have another problem and the message won't go through properly. So obviously have the same byte size on both ends is what I'm trying to say. Do we need everything here? Receiving host ID always gonna be 1. In this case, there's no web host. We're still going to keep that information because we need to have a parameter for the receive function to send that information to. Connection ID is also going to be always 1. In this case, it's always going to be the same person, the server in this case. And channel ID, this can change. Not in our application, but in the second part of the tutorial, this will be able to change depending on what kind of message we have. Here, it can't, simply because we only have one channel in our whole application. Okay, so going down there, nothing, yep, that's totally fine. Connection event, user 0 has connected. Instead of saying that, we'll say we have connected to the server. And let's remove the string.format because we only have this one string. Okay. And over here, we'll say we have been disconnected. And I'm saying we have been disconnected because if you're just closing the application, you won't have a debug.log anyway. So just, if this disconnection happens, it means that you'll have lost connection to the server. Maybe the server went down, but you're still running. But the server went down, so we have been disconnected. If you're playing World of Warcraft or something that's always online, in this case, this would send you to the login screen and tell you to try to log in again. Or something of the sort. Data event stays the same, and everything else just stays the same. Okay, let's do a clear. Let's see what goes on if we press and play. Opening connection, yep. User 1 has connected, and then right after, we have connected to the server. So we've done it. We're now connected. Cool. Now, last time I went and I recorded the whole tutorial, this is the third time I recorded, I had to create a third episode completely about trying this out on WebGL. Multiple reasons in there, and I'm going to explain myself before I go any further. Like, basically, the episode is supposed to be over here, but we're going to cover the WebGL part right here, right now, because I found a much more efficient way to go about this. So, basically, what I'm about to do is I'm about to improve on what I did last time, and this is a very valuable lesson that my teacher used to tell me when I went to school. Never get attached to your code. If you burn it more often, it's going to regrow better. Basically, just kill it as often as you can, and next time you create it again, it's going to improve. And let me just show you something real quick. So this is the final code for server.cs, which is what I've been using as a reference. What I used to do back in the days, last week, is I used to keep track of which platform user would connect from using a dictionary. So basically, this is a dictionary that says, okay, so this is your connection ID, and the byte let me know whether you're connecting on WebGL or on standalone. The reason this is required is because in our connection code, when we send our message over here, we have to know who we're sending it to. If we're sending it to a standalone or to a web client, it's different, for the sole reason that they're not using the same port. So you're not going to be sending your information through port 26,000 if you're actually sending that to a web. If you're sending it to a web client, you need to go through the web port. Now, what I found out as I was doing this, as I was actually talking about this code, is that you actually know which platform they're coming from because of the receiving host ID. And yeah, so that's what we'll be using instead. It's going to save a lot of time because the user platform is something that I asked the client. So once the client connected, he would tell me which platform he's on. So that was an additional message. That was just additional hustle. So guys, there's always room for improving. I am not out of the loop. What we're going to be doing as a whole over here will be improved on part 2. So just know that's coming as well. Okay, so why am I saying this right now? Because we'll need to know, as I mentioned, we'll need to know who we're speaking to. And not only who we're speaking to, but also which platform he's connecting from, so we can send a good message back to him. having that said, on our client connection event, I'll just add something really quickly for the onConnection event. So we'll say user connection ID has connected through host, and then I'll just put 1 in here. So we're connecting through this very specific host, receiving host ID. And we will be testing this out right now, actually. So I've saved that. I'm going to run my server, and I'll be running my client right after. So we'll see which host he's getting. So standalone is getting host 0. So user 1 has connected through host 0. Now we haven't done that just yet, but we're going to compile on our client and build it to WebGL. If you don't have it, there will be basically a button called download extension here, and you can just do that. Once you're done, create yourself a folder inside of your project folder, and then build to WebGL. And make sure you go grab your coffee or something else, because this takes a long time. A very long time. By the way, speaking of waiting a long time, if you're bored during your compilation time, you should very much join us on Discord. Bunch of nice people. This is a VIP channel. You don't see much people here. But look at all these nice people. This side, yep. And we're all here speaking about code, and we're all having fun. And whoa, that was actually quite fast. And it's found 2 of them. Okay. Here's my client. This is my client. Looks amazing. Yeah. So if you want to be running your client in a browser and you want to see your debug.log, you can hit F12 and you're going to see them in your console. Now it's not going to be super explicit. As you can see, I get some problem here. Undefined. Why do I get that? Now as you can see, you're going to get your debug.log right here, and it's going to be followed by a blank line, file name, and another blank line. So you can see connecting from web, so we know which platform we're on, attempting to connect right here to this IP, which should be correct. And you can also see the port it's trying to connect to is the right one. And then undefined will be close. I don't know why it did that. Let me just try that again. Oh, my server is not running. That's why it didn't work. Okay. So let's actually put that back up. Start our server. So my server is running, connecting from 26,000 and also 26,001 for web. I'm going to be refreshing my browser. We'll see our debug.log popping up in a second. Connecting from web, attempting to connect, and we are connected. All those good messages. The client is connected and he is on WebGL. What's cool with this? Oh, sorry. What's cool with this? If you're trying to test out multiple client, it's a little bit easier to do on localhost. As you can see, we can just start a bunch of them, and this is not something you can do that easily on standalone because you have to, have multiple.exe working using your graphic card. This is also the same thing, but it seems easier to me on this platform. And as you can see down here, user 1 has connected, 2, 3, 4. So we got 4 user right there using our server. 4 concurring user. And yeah, let's close the third one and the first one. User 3 disconnected, user 1 has disconnected. Now, what's really interesting in this case that I just figured out as well is have a look what is the channel ID over here, or the receiving host ID, sorry. 65,534. 65,534. 65,535. Okay, so it's one less than that. But it's very interesting to know this information for the sole reason that when we add a web host, it actually goes backward. So you don't start at 0, you start at the maximum value. And then if you were to add 2 web hosts, in that case, I believe it would actually go down from there. Why is it interesting information? Because with this number, we'll be able to know whether the person is connecting from standalone or web. Usually what I thought would have happened is like, okay, so if he's connecting from standalone, he's going to be 0. If he's connecting from web, he's going to be 1. But that's not going to be the case, as we just saw over here. So just something to note. It's quite interesting information to me as well. Something I just figured out, and I wanted to share with you guys. Okay, so I hope this was a little bit clearer. We actually saved quite a lot of time because we won't have to keep the user platform. We'll do it in a different manner that's going to be much more efficient. So I'm super happy about that, guys. Yeah, that's it. Next episode, we're going to start sending message back and forth between these guys. So I hope you guys will join me. I hope thus far you're not confused too much. I know I'm throwing a lot of information out there, but it's all relevant and it's all going to be used eventually. So cheers. See you then.